Welcome back, students. We're going to look at section 1.8, terminology for simplifying expressions. Before we learn our new terminology, let's do a short little review on some terminology that we learned about in a previous video. So remember, the loners are the constants. These are the values or numbers in an expression whose value does not change. They're not grouped with anybody. All right, our next term was variable. These are the numbers in disguise. They represent a known or an unknown value. Then we have our numbers in duets. Those were the coefficients. These are the numbers that are paired up with or multiplied against a letter or symbol in an expression or an equation. Now let's look at our new terminology. Our first blank is going to have the word terms. And that just basically means a number, a variable, or the product or quotient of a number and one or more variables with exponents. And we'll look at what that looks like in just a minute. In expressions, they are separated by plus and subtraction signs, or positive and negative signs. Our next term is going to be like terms, which is what it sounds like, terms that are alike. So terms with the same variables and raised to the same exponents. Now let's look at like terms versus unlike terms. So in the like terms box here, we have 5x and 7x. These are considered alike because the x is raised to the same exponent. The 5 and 7 are different, but that's not what matters. It's the variable. So the variable x is raised to an invisible 1. It has an exponent of an invisible 1 here. We just don't write it because it's just understood to be there. So remove those. So that's why those are considered like terms. Our next example has 4x to the power of 5 and 10x to the power of 5. Again, these are alike because those x's have the same powers. Now let's look over here on the unlike terms and just compare that one with this example. You'll notice it's called an unlike term, and the reason is because the power attached to that x is different. One of them has a 5 and one of them has a 2. Those are unlike terms. They cannot be combined with addition or subtraction, okay? The one above that, when we were talking about the 5x and the 7x, looking over here at the unlike terms, we have a 5x and a 7y. Well, what's different about that one is the x and the y. To be able to combine those in addition or subtraction, we would need both of them to either be an x or both of them to either be a y. Or you could have a situation like this, 5xy and 7xy. As long as they have the same situation here, then they're considered alike. If they don't, if those are different, then they are unlike terms. All right, now back to the like terms side. Let's look at this one right here, 2.5 times AB and then 8 times AB. So we have AB and AB. That's alike. So those are like terms. Now on the unlike side, we have 2.5 BC and 8 AB. Well, you'll notice they both have a B, but one of them has a C and the other one has an A. So those are not alike. Those are unlike terms. Our last example is 3 times P to the power of 7, RS, and then 25 times P to the power of 7, RS. Those are the same. The P's both have the power of 7, and the R and the S both have a power of 1. So we're good there. On the unlike side, the 3P to the power of 7, RS, and then the 25P to the power of 7, that's the same so far. We have 2 P's to the power of 7, so we're good so far. But then notice the R. The R has a power of 4, so it's now different than the original R. So that means they're not alike. It has to match completely. All right. So let's look at combining like terms. 5x plus 7x. First, I need to notice whether or not our x's are the same. They are both to a power of 1. so I can actually combine them. I'm going to add the numbers 5 and 7, and I'm going to get 12. The x doesn't change. It just stays x. Look at the next one. 4x to the power 5 minus 10x to the power 5. First thing I need to look is see if can I actually combine them. Are they like terms? They are. Both x's have to the power of 5. Before I combine them though, I'm going to do the keep it, change so that I can actually do that. So it becomes plus negative 10x to the power of 5. I have two different signs, so I need to take the difference, which is 6, keep the sign of the larger one, which was the 10, and then the x to the power of 5 stays the same. And that is our answer. The next one has 2.5ab plus 8ab. They are the same, so I can combine them. So I'm going to end up with 10.5ab. Our last example has negative 3p to the 7rs plus 25p to the 7rs. They are the same, so I can combine them. I do have different signs though, so I'm going to take the difference, which is 22. Keep the sign of the larger number, which is 25, so it's going to be a positive 22. And then I'm just going to rewrite the p to the 7th power rs, and that is our answer. All right, so we have certain guidelines that we have to follow when we are simplifying expressions fully. So the first guideline is all grouping symbols have been simplified and removed. Okay, so that's the first thing. The next thing is all like terms have been combined. And then the last thing, operations. And what I mean by operations are plus, minus, multiplication, division have been performed. When possible. Won't always be possible, but if you can, go ahead. All right, so this is what we need to focus on. And you need to go in that order. So this would be first, deal with our grouping symbols. Combine all like terms if you can. And that's going to be done through the operations of addition, subtraction, multiplication, and division when possible. So let's look at some examples here using these guidelines. All right, so number one, we have 10x plus 3, and then in parentheses, negative 2 plus 8x. I cannot combine negative 2 and 8x. Negative 2 does not have an x, so I cannot combine it with that 8x. So at this point, I need to use the distributive property that we talked about in the last lesson. I'm going to distribute that 3 to the negative 2 and to the 8x. So I have 10x. I haven't done anything with that. I'm just going to rewrite it. Plus 3 times negative 2 is a negative 6. 3 times 8x is a positive 24x. Okay. I can multiply 3 times something with a variable. They don't have to match. It just has to match in addition and subtraction. So that's key. All right, so now I need to look at my problem. I've got a 10x and I have a 24x, but I also have a negative 6. So I have to figure out what I can combine. I have to figure out what are like terms. Well, the terms that are alike are the 10x and the 24x. So I can combine those. So 10 plus 24 is 34, and I keep the x. I can't combine anything with a -6, so I just end up with plus -6. And that is my answer. Now, the computer, when you enter your answer, it may want you to simplify it one step further, which would be 34x minus 6. So we would undo the keep, change, basically work backwards. So just think of it like this. A positive, this plus sign, times a negative is in fact a negative, which is a subtraction sign. So depending on what the computer will accept, one of these answers is what you'll put in. Let's look at number 2 now. We have 4s plus 7 minus 4 times a -2 minus s. We're in the same situation. We cannot combine the -2 and the -s together because they are not like terms. So we need to distribute this -4 to both items. I'm going to rewrite the 4s plus 7. Then I have -4, because that's what this minus sign means. -4 times -2 is a positive 8. So that becomes a plus 8. A -4 times a -s becomes a positive 4s, a plus 4s. Now I need to consider what are my like terms. I have 4s and I have 4s here. Those are like terms because of the s's, not because of the 4s. So don't get that confused. And I also have a 7 that is a like term with an 8. That neither one of them have a variable or an exponent. So they are considered like terms. So my 4s plus 4s is 8s. Then I have my positive 7 plus a positive 8. And that would be 15. We are now done. That can't be simplified any further. All right, let's look at number 3. We have 6d minus d. So to understand how to solve this one, we have to understand that this minus d actually has a invisible 1 here. We're actually saying we have 1d. We just don't write the 1. It's just understood to be there. But I'm going to write it just so you can see what that means. So 6d minus 1d is going to give us 5d. Basically what this is saying, we have 6 d's and we lose 1d. So we have 5 d's left. All right, number 4, k minus 9 plus k. This is another situation where we have an invisible 1. So I'm going to rewrite it here just so you can see it. Okay, so that -1 that we just don't write is there. I'm going to distribute now to both the items within that parentheses. So I still have the k. -1 times 9 is going to be a -9, so we have -9. -1 times a positive k. A negative times a positive becomes a negative, so that ends up being a minus k. Now, I'm going to rewrite this again and show you the invisible ones. Because remember over here, when we had the d by itself, that's the same as 1d. We have the same situation with these k's. So we got 1k, and then we have our -9, and then we have our minus 1k. That's basically what that is saying. Our k's are alike, so we can combine those. K minus k, 1k minus 1k. 1 minus 1 is 0. So we end up with 0k. And we have our -9 still. We can't combine that with anything. Now, remember that 0 times anything, which is what this is doing, 0 times k, 0 times anything is just 0. And then we still have our -9. 0 minus 9 is -9. So that is the answer for that particular problem. Now let's look at translating words into mathematical expressions and then simplifying. Let me erase this here just so it's not a distraction. And we can actually move our page up just a little bit more. All right, so number 1, we have the sum of 15, 3 times a number, 2 times a number, and 5. So basically it says the sum of, and then it gives us a listing of what all is being added. So that's how we're going to write this out. So the sum of 15, 3 times a number, 2 times a number, and 5. So this is the listing of all the items that are being added together. Now I need to look and try to figure out what I can put together and what I can't. 3n is a like term with a 2n. 15 is a like term with 5. So 3n plus 2n gives me 5n. 15 plus 5 gives me 20. I meant to change the color there. 20. And we cannot combine anymore. We are done. Right, so number 2. The product of 7 and a number subtracted from the sum of 3 times the number and 9. It's a lot going on in there, right? So let's just take it a piece at a time. The product of 7 and a number, so that's 7n, 7 times n, subtracted from. That's one of those turnaround phrases, okay? So I know I'm going to write that product of 7 and a number after something else, so 7n. And I know it's being subtracted from something. So what is being subtracted from is the sum of 3 times the number and 9. So it's being subtracted from the sum of 3 times the number and 9. All right, so nothing changes what's inside this parentheses, and there's nothing outside of it that's going to change it. So I'm just going to bring that down outside. Okay. Now I need to look for like terms. These two are alike. Nothing is alike the 9. So it's not going to combine with anything. But before I combine my 3n and my 7n, I want to change the order a little bit to group them together. So I'm going to have 3n. I'm going to bring this minus sign with it, minus 7n, and I'm going to take the plus with the 9 because it's directly in front of it. So whatever sign is directly in front of something, take it with it, okay? Now the reason I did that is so that I can actually do my keep, change, change. So 3n plus negative 7, and then keep the plus 9 the same. Okay, I didn't change the value of the problem. I just shifted some order so that I could actually work on combining. All right, so now I have a positive 3n and I have a negative 7n. That means I'm going to take the difference, which is 4n, keep the sign of the greater, which is the 7, so that's a negative 4n, and then bring down my plus 9. And so I am done at this point. All right, number 3, 4 times a number added to the sum of the number and 5. All right, so we've got our 4 times a number added to the sum of, so that means I'm going to be adding something over here, the sum of the number and 5. So the sum of the number and 5. Again, there's nothing that's going to change within that parentheses, and there's nothing outside the parentheses like a negative or a subtraction sign. So I can just bring it straight down. Now I have a 4n plus an n and a 5 by itself. Don't forget this n has an invisible 1 to it. So when I add a 4 plus 1, I get 5n. I had 4 n's, I added another n, so I now have 5 of them. And then I bring the plus 5 down. And we are done. All right, let's look at our Bible verse for this section. So if there is any encouragement in Christ, any comfort from love, any participation in the Spirit, any affection and sympathy, complete my joy by being of the same mind, having the same love, being in full accord and of one mind. Philippians 2, 1 through 2. All right, guys, I'll see you in the next video. Bye.